My name's Rob. This is a course on an introduction to statistics for the psychological sciences. And this is the third part of a four-part lecture. Thus far, we have discussed statistics and how it fits in to the scientific method, how scientists use statistics. This is going to be a very short lecture where we review some pretty simple mathematical concepts and notation. So I will spare you the expense of me rambling on and just dive right in to cover this material. So most of this you will have seen before. But so when last lecture we discussed independent variables and dependent variables. So an independent variable, you can think of it as a predictor variable. It's something that we suspect is going to cause a change in some outcome of interest. The independent variable is also the variable that if you're conducting an experiment where the researcher controls or manipulates that variable. When we're mathematically referring to an independent variable, we will call it x. So x refers to an independent variable. And then we can refer to, typically when we collect data, we have a variety of different participants. We have a sample of participants that we've collected data on. X sub I is going to refer to any individual score on the x variable. So I could say x sub 2, and this is going to refer to a specific score or datum, right, on the x variable. In this case, the value of x for the participant who's number 2. They have an ID of number 2. So x bar refers to the mean of x. So mean, average, you all are very well versed in how to compute an average. You add up the total number of the total of all the scores and divide by the total number of scores. Okay, so when we want to refer to the dependent variable or the outcome, we use the notation of y, right? So x predicts y. N is going to refer to the size of the sample. So how many people that we pulled from a population and measured, the number of those people is n. So if we look at the data presented on the screen, what would you say n is in this sample? Well, 3. There's 3 people. What about x? Right? Well, that question you can't answer, right? I mean, what is x? Well, who's x? Right? X could be Anne, it could be Austin, it could be Sally. Right? So we need more information. What about x sub 2? Well, that's going to be 180. And what about x bar? Well, if we do the math, if we add up 170, 180, 190 and divide by 3, we get 180 as well. So I hope that makes sense. So the key thing here is x is the independent variable, y is the dependent variable. X bar is the mean. So whenever we are doing basic computations, it's important that we follow order of operations, right? Most of you will remember this, PEMDAS, right? Please excuse my dear Aunt Sally. If that doesn't do it for you, you can check out the Wikipedia article on PEMDAS, and they have a variety of other, sometimes vulgar acronyms that you can use to help you remember PEMDAS. So what is it? Well, PEMDAS just means what do you do first, what do you do second, what do you do third whenever you're doing a basic math problem. So P refers to parentheses, those come first. after you work out things in parentheses, you're going to do the exponents, right? So if you're squaring or cubing something, then you're going to do multiplication and division. Then you're going to do addition and subtraction. Okay, so now let's move on to summation notation. Now this is very simple, and we do it intuitively when we compute an average. We compute a sum of a series of numbers. But the way that this is written out can look scary for people who are not comfortable with math. But basically, in stats, since we're dealing with series of data, there are going to be many times where we have to add up a bunch of people's data to compute, for example, a mean. So when we're adding up a series of data, we use the sigma symbol. And sigma stands for summation. Sum it up. Now, summation is going to occur in between multiplication and division and addition and subtraction in the PEMDAS order of operations. So let's see what it looks like. So here we have sigma, and then on top of sigma, we have the upper limit, and underneath sigma, we have the lower limit. So you're going to sum up the data for values 1 through n. And you're going to do it for variable x, which is the argument, right? So we really have three pieces of information when we have sigma. The sigma symbol is saying sum up the values, but you need to know which ones. So you need a lower limit and an upper limit. Lower limit is below sigma, upper limit is above sigma. And then you need to know what values that you're summing up, and that's x. So here we can see that, sigma of 1 through n on variable x is what we're going to be adding up. So let's look at the data that we had before, because we already had done a summation when we computed the average. We look at the formula. So x bar, which is the mean, is equal to the sum from the first person to the total number of people on the variable x. And then we divide that sum by the total number of people. So it's actually a very simple computation. It just kind of can look scary if you're not familiar with it. So in English, what this is asking us to do is sum up all of the data points for x and divide by the total sample size. So if we do this, it's as simple as 170, 180 plus 190 divided by 3. We get 180. You did this in your head right out of the gate. So don't get bogged down with how the notation looks. Okay, so this was very short. I want to thank you for listening. I hope everything in this video makes sense. We're going to be leveraging your understanding of this in subsequent lectures, particularly when we get into correlation and regression. We'll be using a lot of x and y variables. We'll be doing a lot of summing up and dividing by n. But for now, I look forward to seeing you in the fourth and final part of this lecture series, and have a good day.